All right, welcome to the next video in our series in programming in Java. This is, I think, going to be the fourth video in the object-oriented programming playlist. At this point, we understand that we're going to be making helper classes to support a client class. Those helper classes are going to have state and behavior, and that state is made up of variables. Well, when I originally framed the problem that object-oriented programming solves, I said it's going to save you lines of code to be able to have a type that you've defined like dog, and each dog object like D1 holds a bunch of variables in it. But I think, and the astute observer would say, well, sure, you were able to make a bunch of variables, but then you had to go through the trouble of setting them all. And even with setters and getters, that's still a lot of lines of code, right? We've got set name, set age. I'll dot access the third one because it doesn't have a setter yet. D1.facts equals true, and maybe we're saying there's a, you know what, I'm going to get rid of the static variable just so that it doesn't cause total confusion. Okay, that cleans that up. So here you're thinking to yourself, well, creating dog didn't save me any lines of code. I still had to go through the hassle of setting all this stuff. In comes our good friend, the constructor. So to define your own constructor for a helper class, you're going to do something that's going to look a little weird. It's going to look like a method, but it's missing a key important thing. I'm just going to say public dog. And you might be thinking to yourself, wait a minute, you missed something. It should say string or int or void or something. Well, we know we're looking at a constructor when there is no return specified. This is not void. I'm going to say that again. This is not void. We don't say public void dog because that would be a method that has no return type. We're saying, look, when you construct a new dog, this is the code we want to have run. There's a lot of different ways to do this, but the way that I'm going to recommend is go ahead and take in a parameter for each field you have and assign that parameter to that field. So what does that look like? It looks like string name and int age and boolean vax. And then inside this constructor, I'm going to say whose name, this object I'm just creating gets the parameter that I was given called name. And this age equals age. And this dot vax equals vax. And you might recall from the previous video, the purpose of the this keyword is so that Java doesn't get confused what we're talking about. You know, every dog object's got these variables of its own. So to help make sure that dog is not confused, am I talking about name, this variable I own, or name, this parameter I was just given? We use the this keyword. Could we get around this project by saying string n and then just saying name equals n? I mean, you could do that, but you get yourself into a situation where you're working hard to come up with alternate names for your parameters, and that just seems like a waste of time. Just use this. This communicates very clearly what it is that we're doing. So why do we make this constructor? What is this piece of code we're looking at? The constructor is the code that gets run whenever we make a new dog object. You might notice now that if I go back to my original code, the code that I had written, dog d1 equals new dog, no longer works. That's because we've specified a way that we want our dog objects made. We're not allowed to make a dog object unless we pass in those three pieces of information. So I'm going to say new dog boomer for name, that was the first parameter, 2 is his age, and then true is his being vaccinated. This means that I don't have to use any of these other lines of code. And now, whoops, put that back. And we can go ahead and delete that. And I'll delete that. Now we can finally see how making the helper class dog is saving us time. Because I was able to make a variable that stored 3 other variables in nice, neat locations. And if ever I want to go get those, we should be defining getters. But I will say, I could just say d1.name if I needed boomer, or d1.age if I needed his age,
or d1.vax if I needed to know if he was vaccinated. So it becomes a very quick, very easy way to create a new object and store a bunch of variables inside that object. That's why we have constructors, is to save time in variable assignment. It is totally possible to have multiple constructors. So we learned this when it came to writing methods. When you write two methods with the same name but different parameters, it's called overloading. And you can do constructor overloading too. I can say, you know what, sometimes I'm going to make a dog, and all I'm going to know about that dog is I'm going to know its name, but I'm not going to know any other details about the dog. So what you do in that situation is you're going to be like, all right, look, this dot name equals name, the parameter we were given. But then let's put some values in that maybe communicate we haven't set these variables yet. The default, I should mention, whenever I make a new dog object, then all of the fields get their 0 equivalent. So age becomes 0, vax becomes false, and anything that's non-primitive becomes null. So name started out null. So why don't I go ahead and I'll just leave those values as is. So I could just do this, or if I wanted to very clearly communicate what was going on, I might say this.age equals 0, and this dot boolean equals false. And if ever I look at my records and I see an age 0, this dot boolean, this dot vax. If I see a dog whose age 0 and vaccine record is false, maybe I'll know that I forgot to update those things. I've seen people put in placeholders for things that are impossible and crazy to remind them that it hasn't been set yet, like integer.min value. If a dog is negative 2.1 billion years old, maybe we'll remind ourselves, oh yeah, I haven't entered the age yet for my dog record. Another sweet trick you can do is you can take advantage of one constructor inside another constructor. So this second constructor I've made is useful, but it's more lines of code than I need. What I'm allowed to do, if you can believe it, is I can say this, and then I'm going to go name, age will be 0, and false. So take a look at that, see if you can figure out what this is doing. And maybe you can tell that I'm using the this keyword a little bit differently now. Now I'm saying, you know what? Rather than make sure I identify the correct field, this is going to be used, when I use this and then parentheses, I'm talking about a constructor. And so I'm saying, hey, make me a new dog. All I'm giving you is a name. And then this constructor will say, all right, I'm going to ship these 3 pieces of information up to this other constructor I have. And I'm going to build your dog with the name you gave me, but age will be 0 and Boolean vax will be false. So that's why typically when I'm making my helper classes, I'll make a comprehensive constructor that can handle all of the pieces of information. And then I can refer to that if I need some other specialized constructors. It's pretty common to make the constructor that handles all the variables, and then you'll see a lot of folks do the one that handles no variables, no parameters, and they'll just ship up like null, 0, false. And this will be a way to make sure if I need to make a dog object quickly, I don't know any information about it, I can make the dog, I'll put in all this placeholder information for now, I'm going to use this comprehensive constructor I've defined, and we can get on with things. I'm sure a lot of you noticed that when the program started, when we started recording these videos, the line of code dog d1 equals new dog, that successfully ran. I guess I should separate these two right now. I was able to write this line of code having never made a constructor. This is a cool thing that Java does for us, but it does it behind the scenes in kind of a sneaky way. And if you don't understand what it's doing, it can trip you up later. So why did this work at first? Well, here's the rule. Java provides a default parameterless constructor, meaning that if my class just consisted of the state and I had no behavior, then it would provide an invisible constructor for me that says, look, you can make a dog object. It's basically would look a lot like this one right here, where it says, we're going to assume it's null, 0, and false for right now until we're given pieces of information. The thing about the default constructor is once we define a constructor, the default is removed. And we saw that before I had this public dog constructor defined right here. Then we noticed that when I made this declaration right here, once I defined the constructor that says making a dog requires these pieces of information, then the default stopped working. So in summary, Java provides a default constructor until we provide one. Once we provide one, if the one that we provide requires parameters, the default one stops working. So why do we have constructors? Constructors allows us to, at the time we create the object, quickly take values, assign them to their correct fields, and move on. And it's a big reduction in lines of code. Please, the last thing I'll say is make sure you have nothing. It's a very common mistake. Students all the time want to add the keyword here, void. That converts this from being a constructor to a method called dog. And that's going to be a totally different thing. So I would not do that. Okay, that was object constructors. Thanks for watching.